वेलकम टू द सॉल्यूशन ऑफ NBHM 2025। इस वीडियो में हम लोग क्वेश्चन नंबर 9 सॉल्व करेंगे। क्वेश्चन नंबर 9 क्या बोल रहा है, ऑन C-11। पहले हम लोग समझ लेते हैं C-11 है क्या। C-11 is equal to all such if such that if from -11 to R is continuous। दिस इज व्हाट C-11। अब इसका एक सबसेट ले रहा है ए क्या ले रहा है, C subset of C-11 such that set of all continuous function from f from I to I। इसका मतलब all such f ले रहा है from C-11 such that image of f मतलब f of -11 is a subset of -11। ठीक है, this is what A is। Now the options are given by A is bounded with both matrices। So first let us discuss the option A। option A क्या है? So first of all, a subset, let X be a metric space. This is a metric space. A subset A of X is called bounded if there is a real number R greater than 0 such that for all A comma B belongs to A, you have the condition D of A comma B is less than R or less or equals to R, whatever। Then we call A is a bounded subset of X। So पहला जो ऑप्शन दिया हुआ है, let us see whether A is bounded with respect to both of these matrix or not। So पहले let us take let f comma g belongs to A। मैंने f और g A से ले लिया। बात कुछ ऐसा है कि f of हम क्या बोल सकते हैं, f of -11 is a subset of minus close to interval -11 and g of -11 is also a subset of -1 1। ठीक है ना। Now let us take let t belongs to -1 1। Now f of t minus g of t, if we take the modulus of f of t minus g of t, हम लोग लिख सकते हैं दिस इज लेसर इक्वल्स टू मॉड्यूलस ऑफ g of t प्लस मॉड्यूलस ऑफ f of t बाय यूजिंग ट्रायंगल इनइक्वालिटी से हम लोग लिख सकते हैं ना। f का इमेज तो -1 1 तक है, g का इमेज भी -1 1 में ही है। सो हम लोग बोल सकते हैं कि g of t से बड़ा होगा और मैक्स टू मैक्स g of t इज ग्रेटर लेस और इक्वल्स टू 1 plus f of t is less or equals to 1। Therefore, what you can say, modulus of f of t minus g of t is less or equals to 2, right? Now, if we take, and this whole for all t belongs to -1 1, now if we take supremum of t belongs to -1 1, we have f of t minus g of t is less or equals to, therefore हम लोग बोल सकते हैं कि therefore d1 of fg is less or equals to all for all fg belongs to A। Therefore the conclusion of this is A is bounded with respect to the metric d1। देखते हैं कि d2 से क्या होगा। d2 का मेट्रिक एक बार देख लो। d2 का मेट्रिक क्या है, इंटीग्रेशन 1/2 इंटीग्रेशन -1 1 fs minus gs dx, right? So again what I am doing, I am choosing a point s in the interval -1 1। ठीक है ना। Now let us calculate the value of gs minus fs. This is less or equals to mod of gs प्लस mod of fs हो सकते हैं ना. gs का मैक्सिमम वैल्यू अगर अगेन 1 होगा, दिस इज अगेन 1 which is equal to 2, right? Therefore modulus of gs minus fs, this is less or equals to, now if we integrate that from minus 1 1 mod of gs minus fs ds, that is less or equals to integration minus 1 1 2 ds, right, which is equal to 2 is range from 1 to minus 1, that is 2 into 2 which is equal to 4, right? Therefore 1 by 2 of mod of integration minus 1 1 mod of gs minus fs ds, that is less or equals to 1 by 2 times of 4 which is equal to 2. So therefore the conclusion is d2 of fg is less or equals to 2, that our for all fg belongs to a. Therefore जो ए जो सेट था वो d2 मैट्रिक्स से भी 2 मैट्रिक के रेस्पेक्ट में भी वो बाउंडेड हो. Therefore what we can say that a is bounded with respect to d1 as well as d2. So option a is correct, right? Option a, you can mark that option a which is correct. Now, so now we'll discuss about the option b. Option b is saying that supremum of fg belongs to a, d2 of fg strictly less than supremum of capital fg belongs to a, d1 of fg. So first what we will do, we will calculate supremum of capital fg belongs to a, d1 of fg. इसका वैल्यू क्या होता है? So for that purpose what I am going to do, I'm just taking two function for option b, but I'm taking two function f of t, this is equal to 1 for all t belongs to minus 1 1, and g of t, this is equal to minus 1 for all t belongs to minus 1 1. So let's calculate d of fg, d1 of fg rather. Okay, so d1 of fg equal to mod of supremum of t belongs to minus 1 1 mod of ft minus gt, right? So let t belongs to minus 1 1, then the value of ft minus gt, this is equal to 1 minus of minus 1, so 1 plus 1 which is equal to 2, and hence supremum of t belongs to minus 1 1 mod of ft minus gt, that would be 2, right? So हम लोग क्या बोल सकते हैं कि therefore d1 of this particular fg is equal to 2, and hence if we take the supremum running over f and g, means supremum of fg belongs to a. Okay, mind it, this both f and g is a real valued function from minus 1 1 to minus 1 1, right? Supremum of fg belongs to a, d1 of fg, that is always greater equal to 2, क्योंकि we got a function, we got two functions f and g for which d1 of fg is equal to 2, so supremum so 2 से ज़्यादा होगा, right? Now I'll prove that, I prove what I am going to prove, supremum of fg belongs to a, d1 of fg, this is less or equals to 2. If I am able to prove that, from that I can say that my conclusion would be supremum of AFG belongs to A, D1 of AFG, that is exactly equal to 2. That would be my conclusion. So for that purpose, what I am doing, I am just taking two arbitrary functions, HK belongs to A. I am just taking two arbitrary functions, H and K belongs to A. Okay. Now I am taking T belongs to -1, 1. Okay. Then what I can say, -1 is less or equals to H of T is less or equals to 1, and -1 is less or equals to K of T is less or equals to 1. That would imply -1 is less or equals to H of T is less or equals to 1, and -1 is less or equals to minus of kt is less or equals to 1. If I add them, I would get -2 is less or equals to H of T minus K of T is less or equals to 2. That would imply mod of H of T minus K of T, that is less or equals to 2. Now if we take the supremum of T belongs to -1 1, H of T minus K of T, that is also then less or equals to 2. So हम लोग क्या बोल सकते हैं, that D1 of HK is less or equals to 2, and that is valid for all HK belongs to A. Now I am taking supremum of HK belongs to A, D1 of HK, that is less or equals to 2. Okay, so the conclusion is, therefore my conclusion is supremum of FG belongs to A, D1 of FG, this is equal to 2. Okay, now after that, uh, for this again, for this H and K, let us calculate D2 of that particular H, F and G. This is equal to 1 by 2 integration -1 1 mod of Fs minus Gs ds, right? So this is equal to 1 by 2 integration -1 1. I took Fs is the constant function 1 and Gs is the constant function -1. This is equal to 2 ds. This is equal to 1 by 2 into 4, which is equal to, and hence supremum of Fg belongs to A, D2 of Fg is less or equals to 2. Fg is less or equals to 2, while we have proved that supremum of Fg belongs to A, D1 of Fg is exactly 2. Now let's see what the option B was saying. Option B was saying this D2 is strictly less than D1, which is not possible as this is greater equal to 2 and this is exactly 2. So this option is not correct. And with the option 2, option B, now we will discuss option C. Option C said that A is closed in the subset this. So for that purpose, I am claiming that, I claim for option C, I am claiming that A is closed in C -1 1 D1. So as मेरा claim है कि A closed होगा, so for that purpose I can prove how can I prove it? So if I take a point F does not belongs to A, और मैं अगर प्रूफ कर सकता हूँ कि A का बाहर के जो मैंने F चूज किया वो that is not a limit point of a, then I am done. To prove that, hence it is sufficient to find, it is sufficient to find an b if some epsilon such that b of f comma epsilon intersection a, this is equal to 5, right? If we are able to find out an epsilon greater than 0 such that b of f comma epsilon intersection a is equal to 5, then I can say that a is not a limit point of f is not a limit point of a. So that is, any point lying outside a is not a limit point of a, and hence is closed in the matrix d1. So now I chose f does not belongs to a. So as a is equal to all such f belongs to c of minus 1 1 such that f of minus 1 1 is a subset of minus 1 1. That is our a. So as f does not belongs to a, then there exists or t belongs to minus 1 1 such that f of t either less than minus 1 or f of t is greater than 1. Then, so without loss of generality, I am assuming f of t is greater than 1. But f of t minus 1 से छोटा होगा, so again we can copy our argument. So last, my claim is f of t is less greater than minus 1. So let us choose an epsilon greater than 0 such that f of x minus epsilon, f of t, that particular f of t minus epsilon is greater than 1. Okay, we can always find an epsilon such that f of t minus epsilon is greater than 1. Now the thing is that as f is continuous at t, then there exists a delta greater than 0 such that for all x belongs to t minus delta, t plus delta, f of x belongs to f of t minus epsilon, f of t plus epsilon, right? That is because of continuity of f at the point t. You can find that. Okay. Now my claim is that my claim is that b of f epsilon, that particular epsilon which is fixed intersection a, is equal to 5. So for that purpose, what I'm taking, I'm just choosing h belongs to b of f epsilon. Now if h is belongs to b of f comma epsilon, I can say that d1 of f h is less than epsilon. So by definition of d1, supremum of t belongs to minus 1 1 mod of f of t minus h of t is less than minus 1 epsilon. Now as supremum is less than epsilon, I can say that instead of t I can take s, as I already fixed a t, so I'm just considering this t as to be s. Now so f of s minus h of s is less than epsilon for all s belongs to minus 1 1. Now as t is also belongs to minus 1 1, I can say that f of t minus h of t is less than epsilon. ठीक है ना? So इससे हम लोग लिख सकते हैं माइनस एप्सिलॉन लेस देन एफ ऑफ टी less than h of t minus f of t is less than epsilon, right? As क्योंकि मॉड्यूलस था, I can balance that. So हम लोग इससे लिख सकते हैं कि f of t minus epsilon less than h of t less than f of t plus epsilon. But note that my epsilon was satisfying the condition f of t minus epsilon is greater than 1. So from this I can say that 1 is greater than f of t minus epsilon less than h of t, and hence हम लोग बोल सकते हैं कि the h का value at the point t is also greater than 1. So this is equal to 5 क्योंकि h भी a का member नहीं है, h does not belongs to. So therefore any point lying outside of a is not a limit point of a, hence a is closed. Is the conclusion? A closed. So we are done with the option C, right? Let us discuss option D. Option D is saying that A is closed with respect to the metric D2. I am also claiming that this is true. So for the purpose, if possible, let A be not closed. Okay, I am assuming that A be not closed. Now, if A is not closed, then I can say that A bar, the closure of A, is बड़ा होगा. Then let us choose, let A belongs to A bar minus A. Now as I am choosing A belongs to A bar minus A, and this is a metric space, then there exists a sequence fn in A such that limit n tends to infinity, fn equal to f of, obviously with respect to the metric d2, ठीक है. Now as f does not belongs to A, without loss of generality I can assume there exists t belongs to minus 1 1 such that f of t is strictly greater than 1. Then we can find an epsilon greater than 0. Let us choose instead of that, more generally we already have done in the previous option, I can say then there exists a epsilon greater than 0 and a delta greater than 0 such that for all x belongs to t minus delta, t plus delta, fx is greater than 1 plus epsilon. This is always possible by continuity of f at the point t. Now since fn that belongs to A, this implies for all x belongs to minus 1 1, fn x is less greater or equal to minus 1, less or equals to 1, right? In particular, if we x belongs to t minus delta, t plus delta, minus 1 less or equals to fn x less or equals to 1. And note that fx is more than 1 plus epsilon. Then I can write mod of fn not just a minute, I'm just choosing let x belongs to t minus delta, t plus delta, and for the particular x I'm just calculating mod of fx minus fnx, where n is any natural number. This is equal to fx minus fnx. Why? As fnx is less or equals to 1 and fx is more than 1. So I can do that. Now this is less than 1 plus epsilon minus 1, which is equal to epsilon. So therefore mod of fx minus fnx is greater than epsilon. Now if we integrate this, integration minus 1 1 fx minus fnx dx, this is integration t minus delta to t plus delta mod of fx minus fnx dx, क्योंकि t minus delta t plus delta जो interval है that is lying between, properly lying between the interval minus 1, so can be equal to, or but some of the cases that is I can take this strictly less than. Now this is, but on this interval this is less than epsilon, so greater than integration minus t minus delta t plus delta equal to epsilon data, so which is equal to epsilon into t epsilon into 2 delta bar 2 epsilon delta. Now as epsilon is fixed and delta is fixed, so for any n belongs to natural number, and that is our d2 of f comma fn. So d2 of f fn is greater than 2 times of delta epsilon for all n belongs to natural number, right? But as we considered the sequence fn such that limit n tends to infinity, fn is equal to f, that would definitely imply d of f fn, which is equal limit n tends to infinity, d of f fn is equal to 0. But this is strictly d of f comma fn is strictly greater than 2 of delta epsilon for, or strictly greater equal to d of 2 delta epsilon, which is our contradiction. So therefore that set A is closed in the matrix D2. So option D is also correct. So that's all about our question number 9. Thank you.